Good day. We're beginning into a new chapter. This is chapter 8, and the subject is on hypothesis testing. Writing is a little bit messy, and as you may remember from in class, I can't think and talk and write all at the same time. So we're going to introduce, first of all, what is hypothesis testing, and make sure we are basically, in good, have a good grasp on the fundamentals of what do we mean by all of the terminology. So let's go into the introduction to what we mean by hypothesis testing. And we will cover the traditional method of doing hypothesis testing. So, our introduction is, first of all, what do we mean by a hypothesis? So, this is statistics. So, here it's a statistical. I guess we could just go ahead and encapsulate that in parentheses. A statistical hypothesis. Okay. And let's see. In the future, probably we'll just abbreviate this as hypothesis, hype, like that, HYP. A statistical hypothesis is a conjecture about a population parameter. Conjecture. What does that mean? That's just a guess. Basically, perhaps it's an estimate. Perhaps it's saying that an estimate is or is not accurate. But whatever it is, it's a conjecture about a population parameter. And well, let's see. We have, for statements or guesses or estimates like this, we only have two possibilities. It could be true or not true. It could be true or false. It doesn't have to be a true guess, right? It's a guess. That's it. All right, so let's move on to, maybe pause the video while I fix this. Let's go to another page. There we go. That's convenient. All right. Let's go over more hypothesis testing terminology. The null hypothesis and the alternative hypothesis are the two main things that we're going to be talking about. Null, and just remember that HYP that says hypothesis. I just invented a new way to spell it. All right, so for the null hypothesis, we're always going to denote this as H subscript 0. And what this is a statement about, this is a statistical hypothesis, so this is a conjecture that says there is no difference between a certain population parameter and a specific value. Or in other words, or another alternative is that there is perhaps no difference between two different population parameters for two different populations. So our null hypothesis is always going to be a statement of equality. All right? So here, I won't really put the technical definition, I'll just put some key features. So this is always a statement, squeeze that word in there, of equality, right? And we'll go over a few examples of this. So here we're saying there's no difference between our population parameter that we're thinking about and some other value, or some other parameter for, that same parameter for some other population. No difference between, that says between. So for sake of argument, let's just say our population parameter that we're considering is the mean, the average value, so that's mu, and we'll say some other value. Okay. All right, so the other piece of terminology, the other main hypothesis that we'll be thinking about when we're looking at statistical testing is the alternative, or sometimes referred to as the research hypothesis. Alternative parenthetical name, research hypothesis. And we denote this by H subscript 1. Okay? And now this is, well, essentially a negation of the null hypothesis. All right? Here the null hypothesis is saying that there's no difference, and so then the alternative, or the research hypothesis, would be saying, okay, well, there is some significant statistical difference between our parameter and whatever this other value was that we were considering in the null hypothesis. All right, so the alternative hypothesis is saying that there is some difference. So here we can be saying that forgot how to count. 3 different ways. So there is some difference. So here is no difference, and here there is some difference between our parameter, let's say mu, and some other value. Okay, so just as an example, switch to green, an example of a null hypothesis would be saying that mu is equal to, just for the sake of argument, let's go ahead and say 3. I don't know. At any rate, that's just an example. And we would, let's make this example a little bit better. We would say H subscript 0. I usually put a little colon right behind it, and I say H subscript 0 is the statement mu equals 3. Right? So here, for our alternative hypothesis, okay, we've got 3 different ways that we could do it, right? So here, I'll just number them 1, 2, and 3, okay? No particular order. Well, no, I'll say some particular order. All right, our possibilities for H subscript 1 would be to say, well, okay, let's say, for instance, mu is less than 3. That would be one way of saying, okay, there is some difference. Okay, there's a specific difference that mu is under whatever this value was, in this case 3, right? Here, another way to say that there is a difference, H1, right? The alternative hypothesis, right, is always H subscript 1. And so we're going to say H subscript 1. Another way to say this is that mu is greater than 3. Okay? and kind of like our third alternative, right? It's kind of like what they call it, the alternative hypothesis, is this, that mu is just simply not equal to 3. Don't know whether it's greater than or less than. I don't care. I just say it's not 3, right? Let's go through a few specific examples, going and stating or identifying the null hypothesis and the research hypothesis or the alternative hypothesis for each of these conjectures. And so we'll take a look here at example 8-1. Okay, this is located on page 416 in your text. And here it says, state the null hypothesis and the research hypothesis or the alternative hypothesis. So I'll just refer to these by their notation, H subscript 0 and H subscript 1 for each one of these, each colon. All right, part A researcher studies gambling in young people. She thinks those who gamble spend more than $30 per day. Okay, so let's begin here. What does she think? What is her claim? One particular way to approach hypothesis testing and make sure that you're thinking about it in the correct way is to identify what the let's say what the point of the research is. What is it that they are trying to prove with this research? And so here, regardless of whatever H subscript 0 and H subscript 1 are, let's see what is it that she's trying to prove. Her claim, or what she thinks, is that young people who gamble spend more than $30 a day. So we're talking about a whole population, all of the young people. And so here, all of the young people who gamble, right? That's our whole population. And so are we going through one by one and tracking each individual amount that they are gambling? Well, yes. I mean, that's the raw data. But what we're talking about here is mu, right? The average amount that they are gambling, right? So she thinks it's more than $30 a day. Okay. Of course, we should put the units of measurement, like a green for money. All right. But, sometimes we get lazy and we don't. So what would the null hypothesis be saying? Well, here, whatever it is that she thinks, right? She thinks they spend more than $30 a day. Well, it could be that they don't, that they spend less than $30 a day. But we're just going to say, okay, look, the average is 30 until I can prove otherwise, until I get some evidence otherwise. Then I'm not going to really have anything to say other than is it 30? Sure. Okay, so that's how we would set it up. We would say the null hypothesis is mu is equal to 30. There's no difference between the average value and whatever this target number was. Okay, and then over here, more importantly, our claim. Sorry about that. Don't want to distract you. Our claim is that mu is greater than 30. So that's the intent of the research. So that's another reason that we call this the research hypothesis. All right, so let's look at another example. In part B, a researcher wishes to see if police officers whose spouses work in law enforcement have a lower score on a work stress questionnaire than the average score of 120. Okay? All right, so here we're saying, okay, out of the whole population of this, this body that is getting this work stress questionnaire, we're looking at this subsection of police officers whose spouses also work in law enforcement and looking at their average test scores. All right. So our population is this specific subset of a a greater population. The population average for the whole, right, for the whole set of test scores, period, is 120, right? And again, we're looking at the claim, right? This is what they're wondering about. So I guess I'll skip the parentheses and just say claim. What they are claiming, or what they are thinking the research might be pointing toward, the intent of the research is to say the average stress score is lower if their spouse works in law enforcement. Okay, so here again, the null hypothesis is a statement of equality. It's saying there's no difference between this subsection of the population and the whole population itself. Doesn't make a difference, apparently. The spouse working in law enforcement as well, they still got equal stress on the job. or the alternative, if we unearth enough statistical evidence that supports this claim, the alternative would say, well, it is less than the average value of 120. Okay, and that would be an instance of the left-tailed test, which we'll get to in a moment. All right, in part C, we're going to find H subscript 0 and H subscript 1. It won't always be the case, but normally, watch and see. I'll just put a little C over here, because normally the claim is the alternative hypothesis, all right? And then you kind of just replace the inequality symbol in the alternative, H1, with an equal sign, and that's our null hypothesis. That's another way that we can kind of approach this, right? Each problem is different, so you have to look at the specific details of that problem itself. In part C, going into the specific details of the problem at hand, a teacher feels that if an online textbook is used for a course instead of a hardback book, it might change the student's scores on a final exam. In the past, the average value for the final exam for these students, for her students, was 83. Okay, so in the past, mu equals 83. If there's no difference, right, it'll just stay at 83. If this, switch from an online resource, to an online resource from a physical hardback resource does make a difference, well then it will not be equal to 83. But here, the researcher, the teacher, does not have any specific idea. She just thinks that it might change it. So yeah, the claim is still over here in the alternative hypothesis. It's what we are trying to prove through the research. And here, they don't know whether it's going to increase test scores or decrease test scores. We don't know. All we know is that, or all we are trying to determine is whether or not there is a difference. Okay, so in this case, when they're just saying, is there a difference? We would just say, well, okay, the null hypothesis is there's no difference, and then the research hypothesis is there is some difference. Okay, let's pause here and pick up in a moment.